Awesome. Okay, so we are going to review key characteristics because I feel like we struggled a little bit yesterday. So let's start with the domain. The domain. The set of all possible what values, x or y. What's domain? X values. Good. The set of all possible x values which make the function work. Do we read it bottom, top, left, right, right, left, left to right? Awesome. When we do domain, we always go left to right. Always. So left to right. Domain is that x-axis. Now the range is kind of the opposite. It's the resulting what values? Y values. Awesome. And how do we read range? Down to up, bottom to top, yes. Well, just takes a little bit, you're good. Bottom to top. And here's your bottom, and here is your top. So domain and range go hand in hand. You have this function, that's why there's this picture there. There's the function. You take your domain values, your x values, you put them into your function. You plug those values in, and it spits out your range, your output, those y values. So again, you take your x values, you put it into that function, that's what that table we were doing, and you spit out the range. That's what the range is. It's all the y values. Okay? And x-intercepts. It's the number pair, and it's located on what axis? The x. It's the x-intercept. Okay? It's the x-axis.
Oh my God.
Always believe in yourself. Don't wait for other people to answer. If you're confident with it, you got this. So it's your x-intercept. It's always an ordered pair. So it's something like maybe like 1, 2, for example. That's an ordered pair. Okay? Don't put that one on there because it's not an x-intercept. Also known as the what or roots of a quadratic function. See if anyone remembers from yesterday. What is another way we can say x-intercept? Is it
Axis?
parabola, axis, vertex? It could be the vertex, but they can also be called the zeros or the roots.
Oh.
Yeah, zeros. And why is that? Because y is 0. That's why it's a 0. Okay. There are situations where you have no x-intercepts, like this one. There are situations where you have only 1. That's when the vertex is on the x-axis. And then there's situations where you have 2. You will never have more than 2 because it's a quadratic function. Okay. If you have x cubed, you will never have more than 3. That's how that works. Y-intercept, it's a location, and it is on the y-axis. Very good. It has to cross that y-axis. So these pictures are really, really great. They point right to what we're looking for. So when you can use this on a test or the final, you'll be able to use those visuals on them. Interval increase and decrease, I feel like this was a harder topic. They're always your x values, always. X value to x value. Interval x value to x value where the function is increasing, okay? You would think that, but it's always going to be your x's for every interval of increase or decrease. You're always using your x values. The only time you use y is if you're using range. Okay, y. When you have increase, it's a positive slope. When you have decrease, it's negative. So here's this guy. He's telling you to read left to right. So if I have my finger on the leftmost point, it's going up and increasing. Then it's constant, it just stays the same. Then it increases, and then it decreases. So when you read functions, you always find the leftmost point, even if it's an arrow, and you read it that way. So if you were doing a parabola that was concave up, left to right. Okay. Here's why we have to keep consistency, because if you read it right to left, this looks like it's increasing, but it's not. Decreasing. You should always start or stop at that vertex point when it comes to parabolas. Okay. It would be to draw that axis of symmetry. So here is your graph. Say we had a parabola that was like right there, and then this was your axis of symmetry.
Can you draw that?
Yeah, you can draw that. Okay. This guy would be decreasing. Ooh, what happened? This guy would be decreasing right here, and this guy would be increasing right here. Okay, doesn't matter which color for this round, is this. It's always, always, always going to be your x values. Okay? Like I heard earlier, a lot of people will try to switch it to the y's. It's always your x values for interval of increase and decrease. Okay. Axis of symmetry. In a parabola, is the vertical what? What is that called? What is this called? A line. Thank you. That's huge because a lot of people will, again, just tell me 5. It's not just 5. It's x equals 5. And it's always going through that x coordinate of the vertex. So here's your parabola. Here's your axis of symmetry. And it goes through that x coordinate of the vertex. It's always going to be x equals negative b all over 2a. Or if you like to say the opposite of b all over 2a. The best part about this, I got it color-coded, so I was able to use a colored printer for these. And you can see the step-by-step process in plugging it into this formula. So in this function, a is 1, b is 12, c is 32, and then they do the work for you. So it's an example for you to look off of if you ever were asked what the axis of symmetry was. Okay. Any questions so far? It's just kind of just going over everything, just another day of making sure that you feel strongly on this. Because we will be doing a lot of graph stuff in this class, because it's a lot of taking Math 2 and going that one step further and analyzing the graphs. Okay. Concavity. It's just going to describe if it's going up or down. It's that leading coefficient. So that leading coefficient is that a value right here. This is your leading coefficient, that a value. If it's positive, it opens up. If it's negative, it opens down. So like I just said, if it's opening up, is it going to be positive or negative? Positive. Positive, yeah. Remember what I said. It's like if you're a positive person, you're most likely smiling all the time or most of the time, and you're putting a smile on other people's faces, so you're opening up. And down would be what? Negative. Negative. And when you're a negative person, you are frowning, you're not a happy person, and so you are opening down. Questions on that? Max and min. The max is the largest y value, so now we're using that y. You use y in range and in max and min. Those are the only two places you use y. Everything else is always your x value. Okay? And the great thing about these graphs that I found last night was that they literally point to what the value is. So what is the max value of this function over here? 1. 1. So my max value is 1. Max value is 1. Okay? If I asked you for the location of it, that's when you would tell me my vertex. But the actual max value is 1. That means it's not going anywhere higher than 1. Okay. We are also using the y value for the minimum, but we're looking for the smallest this time. So what's the minimum y value of this graph? Negative 2. Awesome. So my min is negative 2. So if you always your vertex.
Oh, okay.
Yeah, but you want to look at just the y value. That means what that's telling you is that parabola will never go lower than negative 2 because it's your minimum. Okay. Good questions. Now we're going to jump. When you're done, flip your page so I know you're ready. To some problems, and now maybe it'll start making sense after. That was kind of just like notes again where I was just telling you things, but now let's start applying those concepts. Your 2 highlighters ready to go. We have these 4 graphs. We only did 2 and they felt okay after 2. If we are not okay after 2, then we'll do 3. You kind of need to just be honest with me and yourselves to make sure that we get the best education we can to understand these. Okay, so we have graph A, B, and C. Let's talk about A first. What's the domain of all functions that are parabolas? For all parabolas. Yeah,
Zero.
just reverse. Negative infinity to positive infinity. So what does that mean? It forever goes to the left to negative infinity. It's going to keep going. And it's going to forever go to the right to positive infinity. You're looking at your x values. Okay? So we have negative infinity to positive infinity. And that's for every single parabola. It will not change, so you might as well just write those down. The little... I like start there. Okay. Range is a tricky part. Before we do range, I want to always find the vertex. If you find the vertex of a graph, it's going to help you with majority of your answers. So what's the vertex of A? Graph A.
-2.
-2 what?
-2, -2.
Yeah, -2, -2. Okay, that's my vertex. So now that I know my vertex, let's talk about our range. Remember the range. You have to put your finger or your pen at the bottom of the graph. And the moment it touches the function is where it starts. So there is no function here. No function, no function, boom. Where does the function start?
0.
What value is that? Good, -2. And where does it go? To infinity. Good. So your range would start at -2 and it would go to infinity. Make sure you have your closed bracket. Okay. If it's concave up, you will always start at a number and go to infinity. If it's concave down, you will always start at negative infinity and go to a number. Okay, so it's kind of reversed. It just depends on where it opens up or down. Let's talk about our x-intercepts for graph A. Can someone name one x-intercept for me? Yes, -4, 0 is 1 right here. This guy is your x-intercept. I would label it so you know if you were ever asked on an exam, you would be like, okay, that's where it was. Is there another one?
On the other side.
On the other side, what is that point? 0, 0. So those are my x-intercepts. For prize, does anyone know what also 0, 0 is? Why what?
Y-intercept.
It is the y-intercept. You got it. And it's the y-intercept. Very good. Remember, look, it's crossing the x-axis and the y. It's crossing both. So it's the x and the y-axis, or the x and the y-intercept. So we can go ahead and write that down. I have 0, 0 for the x and the y, because we just established that. And then we had -4, 0. Awesome. Okay, you know, what's the vertex? We know it. We already talked about it.
-2.
Yeah, -2, -2. Okay. Here's a really cool part I'll show you in a second, but let's look at the graph first. Where is my axis of symmetry at? Where would I draw it?
Right in the middle of the U.
Yeah, right in the middle of the U. It's right here. What value is that? What number?
2.
Just 2?
-2.
-2, very good. But always remember to attach the x equals, because it's a line. I cannot stress it enough. If you tell me -2, I'm just going to think you're telling me the point. It's a line. So I'm going to go ahead and write that down here. And here's the trick. If you know the vertex, you can go ahead and just say, hey, that's my axis of symmetry. It's always going to work that way. The x value of your vertex will always be your axis of symmetry. Okay? So if I told you, going off to the side, don't write this, this was my vertex, what would be my axis of symmetry? It would be 5. X equals 5. Involve increase, this is where you need your highlighter. So pick one. I'm going to pick yellow for interval of increase. So if you have a yellow one, just do the same color as me. Then the other color, I don't know what you have. Everyone has different ones. I'm just going to use pink. If you have green, it's okay. So you're always going to highlight your interval of increase with yellow, And you're always going to highlight your interval of decrease with the whatever color you have, the other color. This way that it's always consistent. When you look back at your notes, you can say that's what she meant by the interval of increase. All right, let's look at our first parabola, graph A. I read it left to right, so I put my finger on the most left thing I see. I see this arrow. It's all the way to the left. Is it increasing or decreasing here? Decreasing. So I'm going to use that pink because that was my decreasing. So that's your opposite color that you had. So if you had like green or orange or pink or whatever it was, that's the color you're using. So then it stops here at the vertex of -2. And it increases. Good. So color that yellow. So that you know on that graph that that's where it decreased and that's where it increased. Okay. Got that graph? Okay. So it was decreasing from -infinity all the way to my vertex at -2. Then it switched. Then it started increasing. So it went from -2 to where?
Infinity?
To infinity, yeah, you're right. You will always, always, always have an infinity in the interval of increase and decrease for parabolas. Okay? And you will always use, look how the -2 is so important. It's being used for everything. Okay? The x value of the vertex is going to be majority of your answers. Is it a max or a min?
Max.
It is a min. Why is it a min?
Because it goes to the lowest point.
It goes to the lowest point. If you have a little low point right here, that is your lowest point of the parabola. And is it opening up or down? What's your concavity? It's up. Okay. Good.
Can you wait 1 minute?
Yeah. So we're only going to do one more just because I'm losing you. I don't want to lose you, but it's 7th hour, I understand. But you got to just stick with me for one more round. Okay? So we can drill it in your brain. And then the next 2 columns are going to be the bell ringer on Monday. Okay. Can I? All right. Let's get this out of the way here. So now I want to talk about what if we're concaving down, because it kind of changes things a little bit. So we already know that the domain goes for forever to the left and forever to the right. So it's all real numbers or -infinity to infinity. We already wrote that. Now let's find our vertex. Try to write the vertex down on your own. I want you guys to start doing it on your own slowly. I'll guide you a little bit. But write down first what's the vertex. You try it and then I'll ask for the answer. Tell me what the vertex is. You're just finding it. All right, Brandon, what'd you get?
3 positive 3?
Yep, they're both positive. Good. So that's my vertex. You're good. You need to find your vertex before you can do the range because it's going to help you find the range. So remember, for the range, you put your pen or your finger at the bottom of the graph. Is there a function already at the bottom of the graph?
Mm-hmm.
Yeah, look, I'm touching the red function right now. I'm touching it. So I'm going from -infinity to where?
Positive. 3.
3. See how it stops here? There's no more function after it. If I kept going, then it'd be infinity. But it stops. Yes, the function stops. Okay, so we're going from -infinity to 3, and 3 is included. If you want to make a note to yourself, you can. Like I said, if it opens up, you're always going to start with a number. If it opens down, it's always going to start with -infinity. Always. For parabolas. Okay? Try to find your x-intercepts. Take 30 seconds alone and see if you can find them. Because I know I can, but I want to see if you can. Okay, so take 30 seconds.
Wait, what do we do? Sorry.
Finding your x-intercepts.
Okay.
There's 2 of them. Very good. Even if you can just establish where they are. So what is one of the x-intercepts?
0,
0, 0. What's the other one?
0, 6.
Good. So this is my x-intercept. This is my x-intercept. What also is 0, 0?
The
Y-intercept.
Good. The y-intercept. Okay?
I'm starting to get the hang of this now.
Good.
I was just thinking way too hard. Like
Yeah. Yeah.
like the x-intercept, all you literally have to do is look on the x.
Yes, you have to look on the x-axis. And the y is the same thing. It just so happens to be the same. But if you look at this one, where would the y be here? On graph C.
It would be 6.
Yeah, it'd be at 6. Yeah, very
That'd be
good.
6, 0.
0, 6 was right.
0, 6.
Yeah, because you wouldn't move left or right at all. You would just go up.
Okay.
Okay. All right. Awesome. So let's write those in. I had 0, 0. I know that. What was the other one?
0, 6.
0, 6. Okay. Awesome. We know our vertex. We already found it. It's 3, 3. Okay. Without looking at the graph, because I know I taught this. Yes. Let's see if anyone else can get it. Hopefully no one heard you because I talk really loud. Axis of symmetry. I already told you the trick. If you know the vertex, what is my line of symmetry going to be? Yes.
3.
Good. X equals 3. Get used to saying X equals 3. Okay. 3 is just a point. But you were right. It is 3. Good. And we know that it's always going to be the X value of the vertex. Or you could have went back up to the graph if you didn't remember that and drawn in your axis of symmetry. I always use dotted lines when I do that. Almost there. We got a couple more. Four little boxes. And these two are so easy, so really just 2. Okay. Interval of increase, so get your yellow and your whatever color out, ready to go. Interval of increase and decrease. So, I put my finger at the leftmost point.
Hello.
And it's going to go increasing. Very good. So I'm increasing from here to here. That's my increase. Looks like it's not going to work for me today. It does that sometimes. Well, you just know.
Maybe it doesn't like you.
It, for some reason, does it all the time. Well, you know to highlight this yellow. So if you have your do it right now, yellow highlighter. See how it's increasing.
And then the other one would be decreasing.
Yeah, because it always switches. So even if you watch as I do it, it's increasing, 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 and then it disappears. And then it goes decreasing, 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 decreasing. Okay. I don't know why it's moving on me, so just bear with me. All right, so we were increasing from negative infinity to what point? 3. Good. You're getting used to it.
Can you go on?
That's weird. So again, it was increasing, increasing, increasing. It stops at 3. That's why we use 3. Then it goes decreasing, decreasing. Okay. So it's going to be decreasing from 3 to what? To infinity. Good. Here's where we get confused. Because it's pointing down, a lot of you will say it's going to negative infinity. But remember, we're talking about the x values. It's going forever to that right side. So it's going towards infinity. Is it a min or a max?
Max.
It is a max. And is it opening up or down?
Down.
Down. Okay.